Welcome everyone to the Luxexcel webinar series. After the success of our first webinar where we introduced our technology, today we will focus on the technology behind 3D printed lenses. And in case you're all excited, you can already register for our upcoming webinar on November 7th, where we will dive into the applications of 3D printed lenses. The recordings are available on our website. And make sure when you take a look at the recording to register for our next webinar. So let's start with the webinar today. Our panelists today are Guido Groet, our Chief Commercial Officer, Juan Carlos Duursteler, our Senior Vice President of Application Engineering, Janet Cunningham. Janet is our Business Development Manager and she's based in the US. And my name is Eva Flipse. I'm the Marketing Manager for Luxexcel. Let's not wait any longer. So Guido, can you get started with today's topic?
So thank you, Eva, and thank you all for being here at our second webinar of our series. We will go into more depth of our technology today, but I'd like first to give you a little bit of context of our company. We invented 3D printed lenses in 2009, well, since 2009. And we have really built an amazing team of technologists who can help us develop this technology. And what we try to do is with 3D printing, we can make better lenses, we can make unique designs, and we can make the lenses of the future. And we'll show you a little bit of that today. To remind you what we showed you last time, let me quickly here pass the microphone over to Janet.
So thanks, Guido. And on our last webinar, here's a little bit of what we presented last time. We talked about how our technology produces lenses. So here's a couple of videos. And on the left, what you see is the inside of the Vision Engine, which is our 3D printer. And tiny picoliter drops of our lens material are deposited on a substrate and are cured by ultraviolet light. From billions of drops, we create lenses, and we are the only company in the world that's able to do this. The lens is smooth. It does not require any polishing after it is printed. And later in the webinar, Juan Carlos will discuss more detailed technical specifications of the lenses, such as the smoothness. But what you see on the right is a lens that is being built inside the Vision Engine. But this is time-lapse photography of it. So every time it comes out of the printer, we took a picture, and you can see that it's building as it goes in and out of the printer. It is not being pushed up from under, it's building from the top with the little drops. So this is the method we use to build all of our lenses, no matter the use. This is the core method that we use. Okay, now that we've reviewed the videos together, you can see how we're able to go from a liquid to a lens. So on the left, you'll see a bottle of our proprietary Vision Clear ink, and this is deposited in our printer, and it makes droplets in a very exact position. Many droplets in a precise place is a key to our technology. The result is a lens that's ready for coating if you need it. It doesn't have to be coated, which doesn't require polishing, and has a nice smooth surface. So Juan Carlos, would you explain more about our chemical lab and material development, please?
Thank you, Janet. For our technology to work properly, we need two basic building blocks that need to work together. One is materials suitable to create the lenses, and the other is an ink delivery system that is able to get the right material landing at the exactly right spot. And these two are two things that should work perfectly together. So in order for doing this, we created a team of chemists that work in the material part, but also work and have got a very thorough knowledge about the ink delivery system. What we can say is, as you can see in this spec sheet, it is completely comparable to other materials of wide and spread use in the ophthalmic industry. I would emphasize the high transparency of this material, and also the surface roughness that once you create the lens is comparable or even better than any polished surface that you can get in this industry.
Juan Carlos explained about the droplets, which form a core part of our technology. But of course, the other bit that comes into it is the print platform. Our print platform moves the target, the lenses that we're printing underneath the print heads and builds them layer by layer, as you have seen in the earlier animation. Our platform has the flexibility to print many lenses at the same time, and they can each be different. In the previous slide, you saw the printer was actually printing many lenses at the same time. In some applications, there's a requirement to print fewer lenses at the same time. For example, here in an eyewear application, there are 4 lenses printed at the same time, since they go by 2, of course. And so for this application, we actually changed our platform to print 4 lenses. So the core of our technology, of course, the flexibility. So with our print platform, you can make many different types of lenses. And like in this example here, we're actually printing lenses in different shapes that you don't typically see in lens applications, but for which there is absolutely a need. The key thing is that our platform has the flexibility to print all kinds of different products. The core aspect of the technology is not only the flexibility, but also the scalability. So you saw that before that we print our lenses on a build platform, and we have the flexibility to make the build platform longer or wider. What you can do with that is you can either print more lenses, can increase the volume, the output volume of the platform, or you can actually increase the size of the products that you print. So our technology is really about scalability and flexibility. So in summary, with our technology, you can make many different products. You can mix the products, meaning that you can have different products on one building plate. But we can also increase the size of the building plate. You can make it larger, we can make it smaller. So the key of our technology is really that it's scalable and extremely flexible. So now let me hand it over to Janet, who is going to give you the first introduction to one of the unique products you can make with our technology.
So thank you, Guido. On this next slide, I'd like to discuss a product that we made with one of our partners. They had a need for lenses with a special application, and we created them together. So our customer had a problem, and the problem was that they had a very difficult type of lens that they wanted to print, which had a very high plus power and also a very high prism power. And this is difficult to manufacture. It's difficult in the manufacturing process, it slows down the lab, and it's just hard for them to create. It needed to also look better, it needed to be thinner, needed to be more comfortable for the patient. So we worked together to create a solution to the problem. Our printing process does not require any special manufacturing skills. It's using our software called Vision Master, and we just use 3D printing to optimize the custom lens design. We created a brand new form factor for this lens that could not be created with legacy manufacturing, and they were able to create it. So on the next slide, here's some up close look at the product. So on the top, you can see the same power, but our lens on the top is 3D printed, and on the bottom is a traditional lens that's made in legacy manufacturing. So again, it is high plus powers combined with high prism, and the product is disruptive on the flow in the lab for them to make with generators and polishers. They kind of have to stop and recalibrate everything, and it really creates a problem in the lab unless they're just making a lot of them, which they don't because this is unusual. So the benefit of 3D printing this lens is the form is much better. You can see it's much thinner. It's going to be so much better for the patient because if you can imagine wearing those glasses in the traditional lens, that would be sitting right on your face and it would get oily and it would be hot and the vision would not be as good because it's really thick. So in the thinner lens, you're going to have much better visual acuity. And the great thing for the customer is there's no special skills required to make this lens. You just print it like any other lens that we have. So Juan Carlos, would you show us some more products that we can create with our 3D printer?
So let me show you something that is very unique about our technology, and it is a pretty interesting advantage of it. So as we have said before, we have droplets that come out of a printhead and land into a substrate, and then we build from that lens on any shape that we have been seeing before. But this very technology makes it possible to integrate some features. So we can drop the things, we can create one half of the lens, and then put on top of this, stopping the process, put on top of this first part a foil or something, an object that has some functionality that can be tunable or not, but you can place there. And then we continue building the lens so that in the end, what we get from that is the integration of some functionality via a foil or via a waveguide or you name it into the lens. An example of this you can see here, it is the lens with the foil in between. And for example, another example is the electrochromic lenses that you can see here. What we integrated here is a foil that with some voltage creates a change in the transmittance of these lenses. So you can tune them by regulating the voltage of that. And this has been done using this technique. So now, Guido, could you make a summary of all these things for us?
So, Juan Carlos, thank you very much for this introduction. Let me try to summarize here what everybody has been saying. So, first of all, 3D printing of lenses is here today. We can print lenses today, starting from a bottle of material, generating droplets, and creating these unique lenses. And the key thing is, of course, that because we start from droplets, we can achieve amazing smoothness. Because we use small droplets, we can achieve the precision required, and because we use many droplets, we can achieve the speed. And this really makes it an outstanding and unique 3D print technology. Another key aspect of this platform that we have developed is the scalability. So we can make a few lenses or many lenses. Another thing is, of course, the flexibility. We can make product A or product B in the next, right one or right after another without having any setup times. So it's really a unique, scalable, and flexible technology. Janet has shown us these unique products, optical products that we can make, which are really unique, which actually, whereas 3D printing actually provides a way of making better optical designs. And Juan Carlos has shown us how you can integrate smart technology into lenses. And what you'll be seeing now is that, well, today we can make great 3D printed lenses. And what we will be doing in the next months is we will be releasing unique products that we have developed together with our partners. And these are really products that will change the world of eyewear and of lenses. And this, of course, will raise all kinds of questions from your side, which you have been forwarding to Eva. And Eva, can we start now with the Q&A session?
Thank you, Guido. Before we jump to the questions right away, we now finalized part 1 of the webinar where Guido, Juan Carlos and Janet explained all the details about the technology behind 3D printed lenses. I would like to emphasize that we have another webinar scheduled which will highlight the applications of 3D printed lenses. This webinar will be on November 7th and you can register for this on our website. In the meantime, if you have any questions, you can reach out to us at hello@luxexcel.com. And while we were recording this webinar, you entered different questions in the system, and I consolidated these questions into the 10 most frequently asked questions. So let's get started with our Q&A session. Guido, the attendees would like to know what volume the technology can handle.
Well, like I showed in the pictures earlier, a key asset of this technology is really that it's extremely flexible and it's extremely scalable. So we can print a few hundred lenses in an hour, or we can print one lens in an hour, and the machine can really, or the whole technology, the whole platform can really, has the flexibility to deal with all of that. So if you have an application where you need 2 lenses for example, for eyeglasses, or where you need hundreds of lenses, the technology can do it all. So it might require, here and there some adjustments to the platform itself, but the flexibility is absolutely there.
Okay, thank you for that. The second question of today is how big are the lenses you can print and how small are the lenses you can print? Juan Carlos, can you explain more about this to the attendees?
Yeah, of course. I think it's a good question. So how small can they be? I would say that the minimum size would be on several micrometers, which of course is very tiny, but it would be more on half a millimeter or on the millimeter size. The biggest one would be something fitting completely the substrate that can be, let's say, around half a meter. So you cannot make the Hubble telescope there, but quite close.
Okay, well, thanks for elaborating on that.
Thank you.
Another question is, can we print contact lenses? Guido, can you elaborate on that?
Well, with our technology, what we really do, we build structures from droplets. And so we can build any type of structures, and independent of how it's going to be used. So yes, they can be contact lenses, they can be eyewear lenses, or they can be other lenses. At the end of the day, if you make contacts, of course, it's important that the material is gas permeable, but also that it's biocompatible. And those are things that are definitely on our roadmap.
Another question I received multiple times today is, what things can we insert in lens? Guido, can you explain to the attendees what we can do with inserts in lenses?
Well, absolutely. We can pretty much insert anything you like in the lens. I know that sounds very ambitious, but for example, what we have done is we have inserted all types of foils in the lenses, for example, to create color or to create a certain filter of certain light, but also polarizing filters. So we can insert all kind of passive foils, if you like. Next thing, we can insert our active filters, electrochromic, photochromic, or all kind of other electrically switchable filters. And on top of that, we can also insert devices in there, like LEDs that indicate some kind of information, or cameras that actually detect the outside world, or do eye tracking, or sensors for UV light, or all kind of other applications. And thirdly, something that we're working on now is inserting LCD displays in the lens that actually provide information to the user. It's a little bit hard to be very specific at this stage, because we have a number of projects running which will provide amazing results in the next year, and those are products that we're developing together with a number of technology companies to really create the eyewear of the future, things that you see sometimes in movies, but that with this technology is actually, you can actually make that today, and we're pretty close to bringing that to market together with our partners.
Okay, thanks for that. So, Juan Carlos, in the webinar, we referred to all the cool stuff we can do. However, the attendees would like to know if we can print multiple optical surfaces in the lens.
Yeah, as you know, a lens needs at least 2, or I would say 3 surfaces, 2 of them optical, the front and the back, and maybe the rim, to make it a solid. But this technology has a lot of possibilities, and it makes it possible to make freeform surfaces. It makes it possible to create different optical surface in the same lens. So, and the limit is only the design that, or how reasonable is your design. But in principle, there's no limitation on that.
Thank you, Juan Carlos, for explaining this. Another question I received is, can I test designs before we will work together in a project? Can you explain more about that, Janet?
So this is a good question that we get often, because you, of course, want to see if we can make a product that you want us to make. And the answer is yes, we can do this together. We would work together to see if your design is good for 3D printing, and then work together to make it so that it is optimized if we need to. And then we could create a proof of concept together. And the end goal, of course, is a commercial product which is manufactured in volume in our Vision platform, which we could do either at our site or on your site.
Janet, the attendees wonder if we only print eyewear-related lenses on our 3D printer.
That's a good question, and we have been asked that a lot because we have a lot of competency in the eyewear area. We are the only company in the world that can print 3D print lenses on prescription. So that is a very unusual thing and something that we are very good at. But the technology that we have within our printer and our ability and software is really vast. So we believe there are a lot of other projects that we could do as well. And we're open to working with you and your company on other types of lenses.
Thanks, Janet, for explaining more about this. A question I received multiple times is, are there different materials you can use to 3D print a lens?
Yeah, currently we are printing in one material, but we are developing right now in our chemical department other materials. And in our roadmap is to go into multi-material, which means that you can print at the same time different materials that have different properties. So this is what we are doing on that.
Thanks, Ricardo. So Guido, I received this question a number of times. Can you elaborate a bit on our business model?
Well, first of all, let me say that with this technology that we have developed, we can do many things. We can do amazing things, we can do unique things. Our goal is really to make these unique things in volume, customized to the needs of the user. And so, of course, that requires making sure that what you want to do, our technology can deliver on. And so what we want to do is make sure that that is indeed what we can do. So show us what you want to do. We'll make sure that our technology can do it, and then we'll make sure that it does it in volume, and then we can help you make these products in large volumes, and that's really where we want to go with this.
So this was the last question we addressed during this webinar session. We could not answer all of your questions. However, we will make the more generic questions available on our website. And feel free to contact us directly at hello@luxexcel.com. So the first webinar was a general introduction of 3D printed lenses. The webinar of today gave you more insights about the technology behind 3D printed lenses. And in our next webinar on November 7th, we will focus on what you can do with the technology. What applications are there for 3D printed lenses? You can register for the next webinar on our website. And I would like to thank you all for attending this webinar. Tomorrow you will receive a link with the recording, and we look forward to see you again in our next session.